Hello, my name is Alaaddin Elballa, and my colleague and I are going to be presenting today about our project in software quality management and software quality assurance in IT software and computer information systems industry. Before we go into details about talking about the project, first off, we're going to be talking about an introduction about quality management systems and, of course, software quality assurance and software quality control. And then we will be talking about the systems that we have analyzed in these fields in order to go forward with the project. After that, we will be talking about the process model that is going to be used in the project. And then we will be talking about different types of management criteria that are taken into consideration in the project. First of all, we have to actually define what is a QMS. QMS is the quality management system, and it is actually a set of policies, processes, procedures that are required for planning and execution in the core business areas of an organization. These can include production, development, and service. Now, a process-based QMS enables the organization to identify, measure, control, improve the various core business processes that will ultimately lead to improve business performance. On the side here, we have this graph that's showing what type of policies, processes, and procedures that are going to be in the QMS. Now, the QMS works as an umbrella for software quality management and software quality assurance and software quality control. Again, when defining SQM, it is also a type of management process or procedure that aims to develop and manage the quality of software. The goal of that is to ensure that the process meets the quality standard assumed by the customer and required by the customer, while also meeting any necessary regulatory and developer requirement. And the software is required to be tested on various stages by the software quality managers before it is all actually released to the market. Now, throughout the testing process, there is a cyclical process-based quality assessment that is used in order to reveal and fix bugs before it actually even released. The SQM activities are mainly divided into three types: quality assurance, of course, and quality planning and quality control. Now, to define quality assurance, it is basically the standard that leads to high quality software and the development of a framework of organizational processes. The quality planning is the adaptation for a specific software project and the selection of appropriate procedures and standards from this framework. And then the quality assurance, or actually quality control, is the definition of process ensuring that the software development follows the quality processes, procedures, and standards. The quality assurance always shows around the development section of the project and prior to the development section of the project, while the quality control is always post the development, since it's a reactive and corrective procedure. The system that's analyzed before we started the project include HPLM, Test Trail, Selenium, Jenkins, New Relic, Quaker, GitHub, Texture Code, Postman, Testing Wiz, SahiPro, and Runawix. Now, most of these are web-based, and they are actually tools that help organizations to manage and the applications life cycle, right from project planning and through requirement gathering until testing and development. And then, for example, if we want to talk about like Test Trail is basically a complete web-based test case management solution to actually efficiently manage, track, and organize your software testing effort, while like Selenium works as an umbrella project for a range of tools and libraries that enable and support the automation of web browsers. Most of them provide testing for codes also, and they give detailed results for testing. Here is an analysis for the scope of all of the analyzed systems with the main functions, programming languages, and total line of codes that were found during our research, plus the technical platform and a link to the websites for all 12 systems. The software engineering model that is adapted on this project is the incremental model. And that is because this project is of a medium level of complexity, and it is of an evolutionary type, not a revolutionary type. There have been systems like this made before. And since we will need the feedback from the customer, this would work as the best model for that. Also, by the time the first iteration or increment of the project is done, we will have 60% of the functionality of the project, and on the next second and third and fourth iterations, we will have about 5 to 10% on each iteration or increment. When we want to talk about this code management, we mainly focused on talking about the aim of the project and what kind of characteristics the project is going to have. So the scope of this project is to create a quality management system that ensures the quality standards assumed by our customer and meet all necessary regulatory requirements, as we mentioned this before. And that is achieved by providing more quality and compliance solutions, specifically in two areas: system adaptability to the organization's existing IT and business environment. The system created needs to communicate with other systems that are already in place. And then system ability to deliver critical QMS requirement, since the customer would assume that the system provided will actually fulfill the requirement provided by the customer. These two solutions will provide us with the main quality management system requirement in this project, which are flexibility and control, real intelligence, and enterprise scalability, and seamless third-party integration, fast and easy implementation. We can define the flexibility control by saying that, okay, our ideal quality management system solution is able to accommodate our customers' existing business and IT infrastructure. And the solution provided is truly flexible and can configure all aspects of the software. Now, these can include the look and feel of the user interface and various other things. Real intelligence is actually the ability to accurately see and measure what's happening within the quality system. And enterprise scalability is that, okay, well, if we the QMS requirement dictate that the best system offers users the ability to easily expand to use the software across the organization without huge and difficult technical issues. Just because we do not have an immediate need to expand our QMS right now, it does not mean we will not need it in the future. The seamless integration is that for an organization to be able to integrate its system, it's important that there will be integration options available within the quality management system. And the system needs to be able to connect with the other business systems that customer already have, as we mentioned earlier. So if the software tool is difficult to install or use, regardless of how powerful it is, there is a good chance that it will end up underutilized or never fully implemented. That is why an off-the-shelf QMS system that is a configurable solution like the quality management system we're providing is ideal for our customers. We also want to talk about the constraint on technical platform, and we'll be using HTML and JavaScript, CSS and Java for the front end, and then Java and Node.js back end. And the IDE tool required is going to be Node.bat and Node.bat++, plus the server is going to be Apache Tomcat. The minimum hardware requirement will be a 64-bit dual-core processor with a 16 gig of RAM memory and a hard disk of 250 gigabyte minimum. For the functional requirements section, a web browser is needed, and then an Adobe Flash player or plugin with a 512 kilobit per second and high internet connection. Next, we will start talking about the project cost estimates. So the line of cost based estimation, in our research, we found a few systems with a range of like 400K to 1 million lines of codes. And then this analysis here shows the line of code estimate in our project, and I believe my colleague Anand will be talking furthermore about the cost estimates. Now, when we talk about time management, since when performing the project, a Microsoft project file was created containing all the information, you will see on this slide a snapshot of the file showing all the steps required in the project with the duration and the start dates and finish date provided. The total time the project is going to take is 556 days. And then it's going to be 4 releases until the project is complete. And this is a view of